Well, I think I'm on now. Okay. Thanks, Jen. Well, I'm a little technologically challenged, but I'm here. I've never been to a NARCON, and I've never been a speaker at a rocket event other than R&D reports at NARM, and I usually blow those. But I never dreamed I'd be staring into this camera lens, talking to everyone out there. For those of you that I know, I wish I could see you. I'll do that tonight at social hour. And for everyone that I don't know that's here, I'm glad you're here and wish I could see you too. But I feel good just to be messing around with my rockets again. I got a sore arm. I'm a final responder. So yesterday I got a Moderna vaccine, and that's the best feeling sore arm I ever had. So I hope we can get back soon. You like my shirt? I hadn't worn this shirt in 45 years. But when we were kids, we'd write down the contests on the back of the shirt, and we'd put our patches on there. You know, it was kind of like we were wanting to be as cool as Vern, because he always had that jacket with all of his patches on it. And this makes me think about the rocket gliders back in the 70s. And the contests then, you would have a regional meet that might have 9 or 10 events. And you could count on 6 or 7 of them being gliders here in the Midwest. You might fly boost and rocket glide with a B engine, a C engine, and a D engine. And it was your best single flight that counted. And you got 3 tries to get that good flight, and you had to return it. And so you learned to build these things to handle a beating, because they would end up being flown in all the events. And so what I'm trying to do today is explain some of the tricks for making robust yet reliable rocket gliders that can be flown over and over and over. And that's how you collect data. That's how you improve them. If it's a one-shot deal and they fly away, you don't learn from them as much. And so the idea is to get them back and to keep them going. There's the 2 most commonly DQ'd situations that you'll see when you go to a big meet like a NARM. You'll watch and you'll see shred, and you'll see wings that shear off of fuselages. And the idea with the wings, you don't want them to flutter, you don't want them to fold, so you got to get the good balsa. And I think you can make out the radial lines that are going this way, and that's the C grain. That's the good stuff. And for wings, don't make them thin, make them thick, because that's your structural strength to keep them from fluttering. With your fuselage, that's the backbone, and you don't want to go flimsy there, because it'll be twisting on the way up. It'll be wanting to compound any problems you have. And so I have no problem using big, fat, clunky fuselages. Now, this is for NRC competitors that are starting out. And a lot of times we just want to design, and we want to make them really lightweight. We want to make them, the best glider possible. But you're pushing the envelope. So go ahead and make some beasts. Fly them, they're fun, you get them back, then you improve them. Then the next one, if you want to make it thinner winged or more efficient, go for it. Now, if you're going to be flying these a lot, you're probably going to get them stuck in trees. You might put them in a pond. So I'm going to share with you the way I finish them. And it seems to have worked pretty well for me. I've got some gliders back here that I've been flying for about 12 years now. And they've got a lot of flights on them. But I'm going to show you a couple of wings here. And you can see the finish. It's got a pretty good slick sheen about it. And I'm going to tell you how I do that. Well, right there where it's going to be attached to the fuselage, I'll put a piece of tape on it, piece of 1/4 inch tape. And then you go ahead and you paint them from there. Of course, when you want to build the wing first, you're going to carve the airfoil into it. I generally use a razor plane. These Great Plains sanding bars are great. I understand they're getting hard to find though, but you can really, get a nice straight angle when you're using these. And you'll gradually take them down with smaller, or I should say finer sandpaper. That one's been pretty well ate up, but a piece of 1/4 inch hard balsa makes a great sanding block. You attach it with 3M77 adhesive, but you want to sand them down, and then from there, burnish them. What I mean by that is to get a good quality paper. Here's a plug for my local bank, but it's a nice quality, slick, fine fibered paper. And you tear off a piece of it, and you'll burnish that balsa. And what you're doing is you're getting all the fine fibers mashed down, so it's slick. And then you go ahead and you get out your paint. This is Krylon, fluorescent. Fluorescent, that's the way to go. You'll find them in trees better, out in the middle of a field. But whether it's Krylon or it's Rust-Oleum or it's whatever brand, I really don't see much difference. But you'll paint one side of it, and you'll put it on, and you'll continue to add light coats until it's wet all the way across the whole surface, tip to tip, wall to wall. And then you'll watch it, and it'll dry. And when you see that it's no longer looking wet, and it generally takes about 5 to 8 minutes, depending on the humidity and the temperature, but you'll flip it over and do the other side. Generally about another 10 to 20 minutes. That's when you can start burnishing the paint. And what you're doing is taking another piece of that good calendar paper, and of course you're doing this on a table, but you're going to put it down and you're going to start rubbing it. Now here, it was a little too wet right there where that paint ended up sticking to the paper that it was on. But what you do is you just continue to lightly burnish that, and that is continuing to force those fibers down into the grain. What happens when you put the wet paint on is it soaks in and the fibers want to stand up. And as that paint dries, you can force it back down. And about every 10 minutes or so for the next hour or two, while it's curing, you can continue to polish it, and you'll get that slick finish on it. It's not the greatest finish, but it's a very effective finish for weatherproofing it. This particular model At a TARC launch in June, it landed in a tree. And about 2 weeks ago, I found it at another TARC launch. Anyway, it's faded from the sun, but it's still, not warped. We pulled it down, gave it a toss, still glides like it used to, but it's got thick balsa wings, thick balsa fuselage. It's not the most cosmetically perfect model, but it is very durable. At this point, I could probably sand it down and give it another coat. When you are painting them, you'll want to do the same thing that I did on the center line on the bottom of the wing. You'll want to put tape on your tails where they're going to attach to your fuselage. That way you've got balsa on balsa and you're not gluing paint on paint. Whenever you see wings shear off of fuselages on Boost, you got to figure out a better way to attach them. And what I do is I go ahead and I drill holes. After I've glued the wing onto the fuselage, I'll drill a hole from the bottom of the fuselage or from the top down, whichever it may be. And you end up pinning them together. And what I've been using is bamboo. And they're coming off of bottle rocket stems. And it's a very tough material. And you'll notice that I've got this fuselage that's broken in front of the wing. It's broken behind the wing. But the wing's never separated from the fuse. And it's never broke in the middle. But this is a really good way to keep that wing from not shearing off on Boost. The philosophy about flying gliders that I learned when we were overseas with most of the Europeans, they believe in flying gliders over and over and over. And here in the United States, we're more into designing. And I can really see that occurring. And so I kind of shifted my own ways of doing things so that I did more flying and less designing and less building. And as time went on and I had less time to build, I understood what an asset that was. That's why these old models that are 10 years old, I keep on flying them. On the table behind me here, there's quite a few different varieties. It doesn't matter what you fly, what the design. If you go to the NAR website, there's lots of great designs. The main thing is to fly it, see what it does, tweak it, fly it again. But the main thing for my presentation today is that you want to make it so you can fly it multiple times. So now I'm going to see if we got any questions yet. And the whole time I'm thinking, gee, I hope I'm still broadcasting and not talking to this lens and nobody hearing me. Corey wants to know about installing the bamboo reinforcement. Essentially, go ahead and glue the wing to the fuselage, then get a small drill bit that's a little bit smaller than that bamboo. And you can always sand the corners of that bamboo down to fit your hole. But then push that through and then, put thin CA on it. And let's see, I'm going to try to show that pinned wing again. This one shows it fairly well. From the bottom, you can see here, 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 and here. Now, of course, if you had a thin fuselage, that wouldn't work. So a good, thick fuselage works well. Now, on this one, you'll notice where it has broken in a few places. They generally always are going to break behind the wing or just in front of the wing, whenever they come in and crash, basically. But the wing stays together. And the nice thing about a big fat fuselage is you can glue them back together easily. The break matches up, and a lot of times you can just put them back together with thin CA. Okay, Mark. It may be enamel paint. I know that it stinks whenever you're using it, and I think that's the acetone that's drying off out of it. Well, sorry, I'm not going to read it all to tell you. Okay, we're getting away from the simple stuff here with some of these questions. Okay, Ed Chess, can you discuss reliable methods for transition mechanics? And John Ciliak, for shifting the wings, flap changes. I can go into that if you like. Of course, Ed wanted me to keep it simple. Here's a good question. Dan Wolf, he's talking about the weight of these. Whenever you fill the grain, with multiple coats of sanding sealer, I don't think this is that much heavier. You've got one nice thin film, but it's sealing it up. You're not making a thicker finish. Of course, you're not getting the same finish. And Dan's asking about tissue. And I do not use Jap tissue. I just use that one layer of paint. But I don't think that this one layer of paint really is substantial. It's not that much of a weight gain. Of course, there's a lot more things that are a lot more important than the weight. Of course, you don't want a big clunker, but, still, reliability is more important than a few grams. Terrell's asking if we use the bamboo with the carbon fiber fuselages. No. Generally, with carbon fiber fuselages, if you take a piece of Kevlar thread and run it down the center line of the wing, wrap it around the boom, take it back, wrap it around the boom, what you're doing is you're roping it to the boom. That's how this little radio-controlled rocket glider up here is put together. Whenever you have a small, thin carbon boom, and you're gluing it, to a composite wing, there's not much there holding it together, so you got to give it that little extra mechanical advantage by tying it. Don Carson was asking about dethermalizers. That's the best way to get your models back. On these, I generally use burn fuses. I understand that out in California, you don't want to do that. I understand that here in the U.S. and also with the internets, they're going to be banning burn fuses. At least that's what I hear. Not sure if that's a bad thing or not. Don't need any more fires. We really need a good electronic dethermalizer. Glenn, wanting to know about adhesives. I use them all. Where the I call it the blowhole is, if you're doing a rocket glider, I always want to coat that with epoxy on the inside. Otherwise, it will burn out and you'll come back with your glider on fire. But as far as gluing the surfaces together, I generally use CA, but aliphatic glues work, epoxy works. Epoxy is kind of heavy. Of course, Steve Humphrey's the master of yellow glue. Got to see Steve put one together one night before the event at NARM and actually win it the next day. How do we trim our gliders? Well, honestly, the best way I've done it is to use a radio-controlled electric airplane and take them up and let them go. It's real easy to make a release mechanism to put on the bottom of your glider to do that. Essentially, you've got a servo with an arm on this side, and then a rubber band coming from the other side comes down, has a little thread loop here that goes around the arm of your servo, so that when you activate the servo and it goes full distance, it slips off and releases your glider. I guess trimming gliders could be an entire NARCON session in itself. But whenever you trim them at ground level, you never really see what they're going to do up in the air. If you could get up on top of a platform somewhere and let them go, that helps. Basically, you trim them so that they glide flat and they make a nice turn. Well, we're getting into rocket glider questions. As far as the methods I use, I like to use flaps. That's what these little guys are. They're a lot of fun because you can trim the boost. Here, I wish I had a macro lens on this, but I've got screws, these adjustable screws that hold the wing up. There you can see that the wing is fairly thick. With this area right here being the only area where it is attached to the fuselage, you want to make that strong. That's why I'm pegging it. That's why I'm using a thick wing. The adjustable flaps, this is on Boost. You can trim those so you can make it spiral up. If you need to take some of the up or the down out of them, you can. But when they get to the top, that's where we like to just go straight to the dethermalizer, so they just turn around and come back down, and you don't have to worry about chasing them a long way. That's one method. Back behind me, we've got some swing floppers like Don Carson and Chris Flanagan and some of the U.S. team members fly. I've flown slide wings, pop elevators, no moving parts rocket gliders. That was all the rage back in the early 70s. And it was a pretty educational thing to do. You know, you'd have to build in a little bit of roll on the way up to compensate for them wanting to, you know, pull up. And so you'd have a barrel roll on Boost, and they would transition out at the top into a glide. And a lot of times, whenever the motor quit thrusting, that's when they would pitch up pretty good. It was the down thrust on the pod, which also helped to create the ability for these to fly without having any kind of mechanical shift. Bill Lindsay talks about building built-up wings with monocoat. Yes, did that quite a bit. The last one that I did was a dual egg lofter back when Aerotech was shut down after the fire, and we would use 3 E9s on it. It had a 7-foot wingspan. I was going to bring it today, except I couldn't get it in my truck and it was raining. But it had an airfoil about that thick. It was a thick wing, and it floats really, really well. Built-up wings, they're a little more work than these. You have to jig them, and the monocoat really gives you a heavier finish than what paint does on balsa. If it's a large wing, you know, you're going to have the advantage of a built-up wing. But what we've been doing with all of our large gliders now is using foam cores, or actually using molded wings, which are discus launched gliders that we modify for S8. Richard Ruth, why engine in front of wing versus in a body tube with engine in it? I don't really understand. Could you be more explicit? The other problem with monocoat wings, sometimes at ejection, the embers that are going to be blown out, and I try to make them always blow this away from the glider, is those embers are going to come back and they're going to land on here. Right here is a classic example. And those embers are going to melt that monocoat on a built-up wing. Here's an example a model that just about burned up from its embers. There's a big hole right there. Okay. Using the body tube as the fuselage, you'd have to have a lot of nose weight in front if you were doing a design that had a tail. You know, if you're flying a glider that has, you know, basically a delta wing on it, kind of like orbital transport, something like that. I think the old Estes Sky Dart, it would work well. Jay Marsh. Hi, Jay. Yes. Jay's question is to draw the high point of the wing and shape it down from there. Anything that you can do as a guide to help, do it. I generally shape mine on a piece of glass. I've got a 1/4 inch thick piece of plate glass, and I'll move the wing away from the edge so that this big sanding bar, you know, when the wing's back here close to the edge and you're sanding it, it's touching the edge. And as you move it further away, then it's going to reduce that angle. Of course, you're going to sand your glass down as well. It is going to diminish in time, but that glass is tough stuff. It's kind of hard on the sandpaper too, but you just take this off, put another piece on. Hinge material on the flaps, Mark Bundick. I use Kevlar fabric. I'll use epoxy for that, but I'll take the fabric and I'll cut it, you know, into strips. You know, here's a picture of it. This was not very clean. You can see where the fabric is, you know, flared out. But if you'll take this fabric and you'll mash it with a roller, it makes it flatter. What it's doing is it's expanding those fibers out, and you wet it out with the finishing epoxy, and then go ahead and put that on before you ever cut the hinge. I've bagged them on there, but it's overkill. You know, you can just put it on using a piece of wax paper as a carrier, and just make sure that it's weighted down well, and it'll stick, and it works just fine. Whenever we cut the hinge here, you get your initial cut, but then turn your blade over. And if you use a rounded blade and not a straight blade, the odds of cutting through your Kevlar are less. But yeah, this Kevlar is great stuff. Of course, I've used fiberglass, but it tears in time. And I've used good old Mylar tape. If you have a good finish, that tape works pretty well for a while. Glenn Fever Year. Thinning down the trailing edge. Aerodynamically, you want that to get very, very thin. Practically, you're not going to have the perfect wing that is going to be true laminar on it. And so you've probably got a little bit of mucked up flow going back to where it's probably more important to have that trailing edge a little thicker for reliability's purposes than for aerodynamics purposes. It's always a trade-off whenever we're building these. We're trying to make them the most aerodynamically efficient that we can, yet we're never making them perfect. And so for me to be able to build them in a short amount of time and make them very functional is probably more important than, making them on the cutting edge of efficiency. A quick and easy way to airfoil the wing, a razor plane. It uses the old double-edged razors, from the old shaving razors, and it's a little aluminum job that holds that just like a jack plane does, and you can shave down your balsa much quicker with that than if you're sanding it the whole way. And that's been the method I've used all my time and still do it. Using Cover-Right with foil tape. I'm sure that would work. You'll find out if it ever comes off during boost. And I've had, on radio-controlled rocket gliders, I've had elevators and rudders come loose. And that's pretty much why I use the epoxy Kevlar. Yeah, I like Richard's comment. Rear engine means it does not burn your wings up. That's true. Very true. And I want to put a shout out to Frank Burke. I think he's doing some really fantastic things. And most of his are rear engine gliders. They're not competition gliders, but I think they're attracting a lot of interest from the RC world, maybe over to the rocket world. Yeah, craft radios from the 70s, Bill. I guess to better answer your question, Richard, about why we put the motors in the front, is so that we can fly them with a more controlling tail. Gliding bodies, you don't have much control over them. Now, flying wings, they're probably the most efficient lifting thing out there, but they're so tricky to fly that we just don't do it. And Jay Marsh is saying, speaking of burning the wing, what protection do you apply, if any? Well, with these balsa gliders, I don't use any. Now, with a foam wing like this one behind me up here, I've got masking tape to protect it because it will melt that. And especially if a chunk of that ember lands there and lodges into the surface of it. So it'll hit that masking tape and bounce off. Don Carson, do you have guidance on launch systems for rocket gliders? Rod, piston, towers? What works? Well, quite a few things work. I generally just shoot them straight off of a naked piston. And something I've learned through the years is that you want to have a lot of the motor down inside that tube. I've been at contests where I've flown my pistons much longer than I should have before I cleaned them or replaced them. And I've watched them take off and the piston not move, but they still go straight. And if I only had maybe the diameter of the motor or less inside that piston, I don't think I would have as good a luck as I would have had then. Okay, Ed, getting me back on track here with the NRC people. As far as a young first competitor for a design, go to the NAR webpage and try those. If you're young and aren't into designing your own, or just using the TLAR method, you could get a hold of some kits. I know that Tim Van Milligan and Estes both have some kits, and they're good starters. Rocket gliders for beginners just starting out, that's a little trickier. Sliding wings seem to be the best. They're the most popular with younger flyers that I see, and they work well. Okay, Richard, you're wanting to know about these flaps on here. What activates them? I've got some springs. There's some stainless steel wire that's right here, and basically it's just pushing down on the flaps so that this part here, it's a box that slides back out of the way. And of course, there's a rubber band that's connected from this pin to a hook on the bottom of the box. So that's what activates the wing flaps. A burn string is holding the box forward for the boost. And of course, that string goes up over the port so that when the ejection charge goes off, it burns the string, allows the box to slide backward. The wings come down into a glide mode, but also we've got a dethermalizer fuse up here that's wrapped around. Really, the best way to do that is to use something that burns well, like rod wrapping thread or dental floss, and actually put it through the fuse with a needle, so that whenever the fuse burns down to the desired time that you want it to be in the air, then it releases this lever, causing that flap to go down, and that's how I DT them. Yes, J&H Aerospace has good kits. Yes, good shout out there to Josh. Yeah, he does some good stuff, and he's one of the old free flighters, and he's been to the World Championships doing, I think, indoor free flight. But yes, he does a lot of good things with gliders and rockets. Getting back to Don on the guidance system, a piston gives you a lot more altitude because it's getting off of the piston with a lot more acceleration. And likewise, you need to have a robust glider to handle that additional acceleration. A good way to start is just to fly it out of a tower. A rod works well, but if it gets to be a bigger model with more thrust, then it becomes more difficult to have it come off of that rod. You know, you've got it doing different directions, and it's just more drag getting up. And that's when you need to go to a glider tower. And a tower essentially cradles the wings and the tail. If you're flying in wind, you want to have an arrangement so that the wings, which are in front of the tail, they're leaving the tower at the same time that the tail leaves the tail's tower. Otherwise, the wind will blow the wings backward while the tail's still captured in the tower. Okay, Ed, got about 10 minutes left, and you're talking about designs for new NRC Flyers. And you're talking about one back here. Pretty plain and simple. You got a BG. This is the old Manta style pod where there's just a reciprocating angled piece of wood that captures, the fuselage. Nice robust fuselage. Nice, fairly thick wing. Got good balsa in the tail. This one had clear dope on it, but it doesn't flex much. Straightforward and simple. And of course, the way these fly is the fact that they've got the center of gravity way up in front of the center of pressure. This is probably the best way for anybody to start out. And the best way to get in touch with me would be probably to email me. And I guess I can go ahead and just verbally say it out, and I won't get hacked too bad. But it's KHV, the number 2, the number 6 at yahoo.com. And I would be glad to, answer anybody's questions in the future. If you're interested in some of the things that I've had experience with, I'm more than happy to pass that on. I think everybody that's out there watching NARCON is pretty much the same way. And it's really been quite the event. When I think back of what I'm doing here right now, in the 70s, this never even would have crossed our mind. Ed LaCroix, a good source for balsa wood. That's getting harder and harder to find. It's been my experience that whenever I'll go to Lone Star Balsa or National Balsa, I'll order a bulk supply of it, and half of it is pretty good stuff. The other half is not quite what it was advertised, but if it turns out to be heavier, then that could turn out to be your fuselages. Another good way to make fuselages, instead of buying 1/4-inch balsa, is the leftovers with thinner balsa. For instance, if you had your wings that you're making out of 1/8 inch for, smaller gliders, then your extra balsa, you'll take it and just glue it together, the two pieces. It's a ply fuselage. And that adds some strength, adds the hair more weight because of the glue, but it does a good job. Okay, Bernard, sorry. I thought Lone Star made a return. I remember the fire that they had, and I lost a shipment in that fire. Delties, that's a great starter glider. I saw Bob Alway put one in a thermal and win at a NRC one year. The thermals are more important than the gliders. Yes, there was no flaps on that glider that I just showed. It's not a rocket glider. That's a traditional boost glider. Flaps is getting kind of complicated, and so that's why I was showing it. It was to answer Ed's question about showing a simpler item for some of the younger, newer people that are watching. Balsa USA. Mark Bundick's got a link to that. Well, looks like if you haven't left yet, you'll be leaving soon. It's been a pleasure. We've got about 4 minutes left. Just enough time for me to look at the chat and see what all you were saying. Jim Palmer, good to hear from you. Yes. Thank you, Scott. It's really neat to see everybody who's in here. Just wish we were doing it in person. Thanks, Ed. I'm signing out.